What's up guys, how have you been? I'm really excited to present you this new tutorial video which will be particularly talking about new topics about complex design and the connection with such a connection. You look from my screen, we're talking about the offshore structure design and the connections. So you'll know more information and a demonstration about how you can put and make this, such as a welding a connection for offshore structure. So without to begin the demonstration, is very important to begin by a refresh mind about the theory of detail matter of structure offshore design. So we're talking about offshore structure connection design, but we're not going in deep details, because it's not for the modeling and design. Just is it show some connections matter you always use in the offshore structure projects design and construction in the workshop and on the site. So we'll put one of example and use it in using Idea Statica. So why we're talking about the offshore structure analysis? What is the offshore structural analysis software? There is many, but there is a particularity. Some interesting software for offshore structure design and analysis. You can use Robo Structure Analysis, Tekla, and so. But there is a particular a powerful software developed by Bentley, but it's not the purpose and the topics of today. We're just talking about how to make the connection design. So offshore engineers and the structural engineers need to design, analyze, and simulate the response of offshore platform or wind turbine for a broad range of operating conditions. And capabilities. Offshore design use offshore structural analysis software to solve the structural design of offshore structure, including oil and gas platform and topsides and floating platform. So they can analyze the design operations, the commissions, the life cycle. Offshore engineers can create design that withstand the accidental events such as pushover, ship impact, drop objects, and blast loading. Offshore structural engineers can design vessel hull and primary structure platform for the stability assessment and the motion analysis. They can design more one thing, fix and add that. So these are some different type of offshore design. There is many. There is some floating, and so we can see some difference for the tension leg platform, and so this is some kinds and different methods of design offshore structure using pile and so for the subsea. And so we're talking about for more about in the future for the design such as structure, how to this from design, detailing, analysis, and some prediction drawing for connections design. So today we're talking about the offshore structure connection. Why is it very important talking about? Because the structural detail and connection are fundamental in determining how joint behave and their overall stiffness. So thoughtful design and construction feasibility, particularly when it comes to welding and assemble, are essential for ensuring success. So offshore structure in particular require our utmost attention to this detail, and the structural offshore engine's safety must always be prioritized throughout the entire life of the structure. So is that why that's where idea-static connection come into play. This innovative solution empower engineers to design, simulate, and perform code check on connection with confidence, assuring compliance with various standards such as ASCII, American Institute for Structural Construction, Eurocode, and so it's a versatile setting how allow ease adjustment of partial factors and even let you swiftly generate codes like Norstalk and AP. So in this tutorial video, we will test and simulate a large tube connection for the jacket leg of an offshore structure, enhancing it with internal stiffener rings to effectively stabilize the connection and to prevent any local buckling. Offshore structure demands accuracy. It means it demands precision. So idea-static can make connection design seamless, safe, and code complexity, great insights, enhancing stability. So we will show you from design and fabricate how we can design this such as structure when details matter offshore structure. This is the structural design of our connection tube for our offshore structure, and inside we have some stiffener. We'll show you how we can put it from a digital design to the reality. So as you can see, this is a different model we've been using with idea-static. So there is a kinds of make some design and so on. So we'll begin our demonstration, we begin our design. So the first thing to do is to create a data save. It already exists. So we need to create a new not here, and you select this with this design, create project. You can do it this, for example, create. So we have this form. We can go at this slide. So we need to add we have two diagonal. We need to create other horizontal diagonal. So you need to select this, the diagonal one. You need to copy. After copy, you need to make some rotation. Yeah, we can put 0. We have it. You can put minus. We have this, and you can copy this and put maybe 5 and offset from Z 0. We have not this, we have it. Yeah, we create this. After, we need to create different the diagonal. So we click here, create, copy. we need to put on 200, and we have this. You need to copy and put minus to have this, and click copy to put here 0 and put this here. Not this and this, not the displays. Can go minus. We need to make some offset. We have MAT, so we put here minus 40 degrees. We have this. We can put some offset from 30, so we can see it's almost good. And you can create this copy and change the angle. Okay, so from this side you need to maybe to increase the angle. Yeah, we can put, okay, this is suitable for me, it's okay, and this it's okay for me. Maybe I can change here to see if I put this song. It's very close, very close. I stay with this single. Okay, after we already finish our modelization, so we have this everything, so we must change the parameter of the material. We begin by CH. We click here, we change. We have 46 420. We have 406.420. Okay, we change. After to change, we need to change our diagonal. We must create new, change here, and we put CH 219.1, this. Okay, so we change this too. We change this too. We change this too. And we change this too. After to do this, we need to add, you select this M5, you create a new material, CHAs, we'll use the 168.3, 168.3, 168.3, 168.3, yeah, of course. So we have this, we select this 100, 100. Okay, as we can see here, we almost finish our design, but maybe I need to almost again to put this like this. Okay, to have the symmetry. Okay, after you can see here is the same, this model with this. So after to do it, we need to create firstly the stiffener, our stiffener. So this plate inside our shape, our cut, the first cut, we use diagonal 1 with our CH surface, okay, and not this, and we put here 80, our welding. We select our diagonal 2, M5 with CH, our diagonal, sorry, excuse me, the M5, we select, copy, we put M2, copy, M6, copy, M9, copy, M4, copy, M5, not already done, M8, M7, copy, M8. After we put the connection between M2, M5 and D1, M5 and D1, okay, these two, another welding connection cut between M5 and D2, after connection M4 and D7, M4 and M4, yeah, we can use this, M7 and M4, yeah, cut, M7 and M8, M7 and M8, or M8 and M4. Why, yes, that's okay. We already finished our cut. It looks like good. So the next step is to put stiffener, manufacturing operations. We create plates. You can see here it's inside. We need to change to put it sickle, and we need to change the orientation. We can put 90, not this. You can put 90, sorry, okay. And inside we need to increase the radius for 45, not 45, 180. Transparent, can see here it's almost good. So we can put other offset. The first offset, if we accept it, remember, you can put okay. After we create another stiffener, so we can put the offset 100, maybe we can put a 200. Okay, another it will be 400. Okay, and another 600. Okay, we go to the first stiffener, we made the same, minus 100, we put the same, minus 400, we put the same, minus 600. Okay, so our modelization is almost finished, but there is some before to copy, there is some modifications to do. Editor, we need to put hole and inside 100, 200, it's not enough, 300, not 55. Okay, apply. Okay, we can do the same for the all of our stiffener. So the last stiffener. Okay, so already put the hole, and you can see here there is no difference between all we made and we did here in the picture and our model. So everything is okay, as you can see, everything is okay. Okay, so the next step is to put load. We have a different load. Okay, it's just an example. Okay, after to add our different load for our welding model, so you can just go to calculate. We waiting, you can see. So if you know if you want to know more, 128. So after we check here, we verify the different value of loading apply for our different tube connection. So there was some mistake. I have been enter and wrote the wrong value. So I have been copy paste the right value from Excel file. So after to do this, so you can run go to check, not for to check design and calculate, so we can verify. Wait, good. Yeah, the welding, the ratio is a 43.4. It's okay. Plates it's good, and the good analysis is so to have to for having a ROI, a precision from your design, and to check if everything is okay, you must go to checking some things. For example, to checking for checking the equivalent stress. For example, the equivalent stress weighting. Okay, as you can see here, there is some high stress from this diagonal about the welding, as we can verify here. You can see, and from this side too, you can see, you can go into deformation. So from deformation, see what can be watch. So it's okay, there is no difference between this computer based finite element model, this digital model, and with our workshop, a production, industrial production of this, such as a welding from the platform of from offshore structure. So that was just the important things to talk to you today, to explain you how we can do it, this complex welding connection in using IDEA Statica for structure platform offshore. It's a pleasure for me to present you these tutorials. So please share if you found this insightful, informative. So don't hesitate to share with your network, and subscribe to our YouTube channel to stay in tune and to be updated for our future new updates video tutorial. So thank you so much, and have a good day. Bye bye.